So the rest of section 5.4 is carved out from the beginning part of section 5.4 is because each of the problems need some factoring before I get into the rewriting with four terms in grouping factoring. Each of the problems has at least a common factor. Possibly it has the needs to factor out a negative. And I'm not going to do every one of these problems. Maybe I'll do like at one problem on each page just to keep the video an appropriate length, because I don't think you'll need to see as much, because the common factoring part shouldn't be ridiculous. And then the rewriting it is what we've just done. In problem 20, I look at the numbers 15, 36, and 21. And if I had to, I'd look at the factors of 15. The factors of 15 are 1 and 15, and 3 and 5. Then I'd move to the factors of 36, which are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And then I looked at the factors of 21, which aren't on my screen, 1 and 21, and 3 and 7. So I need to find the greatest common factor for each one of these problems. And in problem 20, because all three terms don't have the letter N, I don't get a letter in my common factor. But if you look at the factors of each of the numbers, there's one common factor other than 1, and that's going to be a 3. So my first step in problem 20 is I'm going to factor out the greatest common factor of 3. Not changing any signs because I didn't factor out a negative. I'm going to divide each of the numbers in the problem by 3 to fill in my parentheses. So the 15n squared, when I divide the 15 by 3, it turns into a 5. I leave the n squared. The first term in my parentheses is going to be 5n squared. This 36 I'll divide by 3, and after the plus sign I'll get a 12. I'll leave the n from the 36n because I didn't factor out an n. And then keep this plus sign, divide that 21 by 7, and get 3. Ultimately, that 3 is going to be in my answer, but it's not going to impact the work that I do to factor 5n squared plus 12n plus, shouldn't be 3, this should be 7 here. I divided 21 by 3. That should be 7. That's a mistake, and it was a mistake that was going to make the next step prime. So usually, if I have a GCF factoring followed by a grouping factoring, the grouping factoring I do off to the side to keep my work easier to follow. Otherwise, I have to start putting in brackets, and it gets ugly to follow. So I'm going to factor this 5n squared plus 12n plus 7. Figure out what it factors into, and then put the two factors after the 3 and call it an answer. So this doesn't have a common factor. I've got that step done. I'm going to multiply the a and the c. The a is the 5, the c is the 7. I'll get 35. This is the row of the template that you should have memorized because there's no minuses in it. I'm searching now for plus numbers that multiply to the number that I just figured out, 35, that add to the number that I haven't messed with yet, 12, and those numbers are actually staring at me because 5 and 7 are the numbers that I need, and they're already kind of on the sheet because 5 and 7 are double positive numbers that if you multiply them, you get 35. If you add them, you get 12. That's going to tell me that I have the ability to rewrite the 12n as 5n plus 7n. Now I'm going to take my problem that started with 3 terms, and I'm going to rewrite it with 4 terms in whatever order I care to write it in, and then split it into halves, and greatest common factor twice. The left half, I factor out a 5n, and it leaves me with an n plus 1. The right half I factor out as 7, and it leaves me with another n plus 1. So greatest common factoring, I'm mostly just going to do it in my head. It's the kind of factoring that most students can do in your head. And if you can't, you'll just have to pause the videos and just figure out the greatest common factoring. It's really important, if you don't have the greatest common factoring perfected yet, get back into and redo section 5.1. You're going to struggle through the whole chapter if you don't get greatest common factoring perfected. So that would be an acceptable answer for 20. Of course, I can always flip-flop my parentheses. I could even move my common factor around, but that would be odd. The common factor is almost always written first. It's the parentheses that we have some flexibility. On this next sheet, I'm going to do 26. I'm just going to do one problem per sheet. And in problem 26, it's ugly. It has both a common factor, because 2 is the numbers, the coefficients of -20, 18, and -4 are all divisible by 2. So I'm going to factor out a common factor, just like I will for each of the problems in the second video, just like I would any problem if I was asked to factor it. If there's a common factor, you always pull out the common factor first. In problem 26, because the first term is negative, I'm going to factor out a negative along with the common factor, or factor out the opposite of the greatest common factor would be the proper way to say that. My greatest common factor is just the number 2. I don't get an x in my greatest common factor because the last term 4 doesn't have an x, and 2 is just the biggest number that divides evenly into 20, 18, and 4. To fill in my parentheses, I'll divide each of the numbers by 2, and I'll switch each of the signs. This negative is going to turn into an implied plus. This 20 I'm going to divide by 2 and get a 10. I'll bring down the x squared. This plus sign is going to change to minus because I factored out a negative. This 18 I'm going to divide by 2 and it's going to turn into a 9. I'm going to leave the x. That minus sign I'm going to change to plus because I factored out a negative. That 4, because I factored out a 2, I'll divide by 2. Ultimately, I'm going to write my answer. And to figure out my answer and keep my work a little bit cleaner, I'm going to do off to the side this factoring. So I'm going to start off, I'm going to multiply the a and the c, which are the 10 and the 2, and I'm going to get 20. This is the second row of my template, so I'm going to need double negatives. So now I'm searching for double negative numbers that multiply to be the 20 that I just figured out, and add to the b, which is -9. And again, I'm just going to save time. I'm going to write those numbers down that I could do in my head. But you can write down every possible pair of factors if you need to write them down. But the numbers are going to be -4 and -5. Because if you multiply -4 and -5, you get +20. If you add -4 and -5, you get -9. So I'm going to rewrite the -9x as -4x minus 5x. And in my efforts to factor 10x squared minus 9x plus 2, I'm going to use this information to rewrite it as 10x squared minus 4x minus 5x plus 2. I'm going to split into halves and common factor in each half. And that right half, I have to factor out a negative with the common factor because the first term to the right of that vertical bar is negative. Between the 10x squared minus 4x, I could factor out a 2 because 2 is the biggest number that divides evenly into 4 and 10. I could factor out an x because both the 10x squared and the 4x have an x, and the x to the first power is the smaller of the exponents. To finish up this factoring to the left of the vertical bar, I divide by 2 and I take an x away, and I'll be left with 5x minus 2. To the right of the vertical bar, there isn't really a common factor. Both terms don't have an x, and 1 is the largest number that divides evenly into both 5 and 2. I can't just leave the right-hand side because the first term is negative. On the right-hand side, I need to factor out a negative 1, create a parentheses, and switch both signs to fill up the parentheses. So the negative 5x will turn to positive 5x. The positive 2 will turn to negative 2. And now I know how to factor the hard part. It's going to be 5x minus 2 and 2x minus 1. Those I'm going to put in the parentheses and call this my answer. And it wouldn't matter if your parentheses were flip-flopped from mine, meaning if you had the 2x minus 1 parentheses first and the 5x minus 2 parentheses second, absolutely going to be okay. On this next sheet, 30 looks a little bit harder than 28. They're going to factor remarkably similarly. I'm going to factor 30 just to keep the video in the 25-minute range. So I'm going to work on factoring the 16x cubed minus 12x squared minus 10x. And first term is positive, so I don't need to factor out a negative. 2 is the largest number that divides evenly into 16, 12, and 10. My first step is going to be to pull out the common factor. The number part of the common factor is 2. Each of the terms in the original problem has an x. The smallest exponent is the x with the 10x. I'm going to factor that one out. Now I'm going to divide all the numbers by 2 and take an x away and be left with 8x squared minus 6x minus 5. Ultimately, I'm going to write my answer, and after the common factor of 2x, it's going to have a double parentheses. And to figure out what goes in that double parentheses, I'm going to work on factoring 8x squared minus 6x minus 5. I start off and I multiply the a and the c, which is multiplying an 8 and a negative 5, which is negative 40. Then my template tells me if the problem is minus and minus, I'm searching for plus minus numbers, smaller number positive, bigger number negative. So now I'm searching for numbers plus and minus, smaller number positive, and they need to multiply to negative 40, which is the number that I figured out when I multiplied the a and the c, and they need to add to this b, smaller number positive, bigger number negative, and the numbers are going to be 4 and negative 10, because if you multiply 4 times negative 10, you're going to get minus 40, and if you add 4 plus negative 10, you'll get the negative 6. So now I'm going to need to rewrite the negative 6x. And if I'm rewriting and I have one positive and one negative, I always write the negative first to make it so I don't have to factor out a negative. So I'm going to rewrite the negative 6x as negative 10x plus 4x. That will allow me to rewrite 8x squared minus 6x minus 5 with 4 terms that we set up for grouping to work. If I pick the wrong breakup, then grouping's not going to work. So I split my halves, do a left half and a right half. On the right half, I don't have to worry about factoring out a negative because there's a plus sign directly after that vertical bar. To the left of the vertical bar, I'm going to factor out a 2 and an x. 2 is the biggest number that divides evenly into 8 and 10. Both the 8x squared and the 10x have an x. I take the smaller of the exponents. So now I'm going to divide by 2 and take an x away. So to the left of my vertical bar, I get a 2x times the quantity 4x minus 5. I bring down the plus sign, And with 4x minus 5, it's another no common factor, which is nice because this allows me to factor out a 1 and leave myself with that common parentheses of 4x minus 5 that I need to have. Done factoring the grungy part, I just need to insert that into my answer. And for an answer, some version of these 3 factors are what you're shooting for. On this sheet, 632 looks to be way harder than 33 and 34 because I have to factor out a negative. So I'm going to work on problem 32, just doing one problem per sheet to keep the video a length that's tolerable, but hopefully giving you enough that you can do these on your own. So immediately, I see that the first term is negative. I know I need to factor out a negative. 2 is the biggest number that goes evenly into 16, 12, and 10, so I'm going to factor out a 2 as well. And now I'm going to finish up the factoring. I'm going to switch the sign here. So this negative sign is going to switch to positive, and I'm going to divide by 2. 6 divided by 2 is 16, divided by 2 is 8. I keep the x squared. This 12, I'm going to flip the sign and make it negative. I'm going to divide that 12 by 2 and get a 6. I'm going to leave the x. And then the 10, I'm going to flip the sign because I factored out a negative. I'm going to divide by 2 and get a 5. And this is another time where I was lazy, or trying to make you be lazy. If you look at what I need to factor in problem 32, and you look at what I just factored in problem 30, well, I already know how 8x squared minus 6x minus 5 factors. I don't need to redo this work. It's not going to factor differently. It's the same trinomial. The work's going to lead me to the same factoring, but I'll flip-flop the order just to give you a different variation of a correct answer. So instead of doing all this work again, I'm not cheating, I'm being clever and just borrowing the answer from my factoring of that because that's what I need. Because that was so short, let's go ahead and do, let's do 33 together then, since that took so little time. So in 33, I need to factor 12x squared plus 10x plus 12. All of the problems on this second part of the video have a common factor. And in this one, the common factors should be easy. It's just a 2. I don't have to factor out a negative because the first term isn't negative. So I can just do that. And now I'm going to go and try to factor 6x squared plus 5x plus 6. I don't even need to look at my template. That's the top row of my template. That's a good place to be. So in my efforts to factor this, I'm going to multiply the a and the c, which are 6 and 6, which are 36. I'm looking for double positive numbers that multiply to 36 and add to 5. This is where things get weird. I'm glad I'm doing this one. So if I look at my factors of 36, double positive factors of 36, 1 and 36 are double positive, they multiply to 36. 2 and 18 are double positive, they multiply to 36. 3 and 12, 4 and 9, and 6 and 6. Those are they have to be double positive, they have to add to 5, they have to multiply to 36. So those are all my choices of double positive multiply to 36. When a problem doesn't have any negatives, you can't put negatives into your factors. Now let me add each of these. I'll add 1 and 36 and get 37. I'll add 2 and 18 and get 20. I'll add 3 and 12 and get 15. If I was allowed to subtract, 4 and 9 would be interesting, but I have to add them, and 4 and 9 add to 13, and 6 and 6 add to 12. There isn't a pair of numbers that do both, that are all three, I guess. Double positive, multiply to 36, and add to 5. That makes this part of the answer in problem 33 prime. But it would be wrong to say the whole problem was prime because I was able to one-step factor. Anytime you're able to one-step factor, you can't write prime for an answer, even if what's left doesn't 2 parentheses factor. So for problem 33, that would be as good of an answer as I can write. Well, I guess we can maybe do 2 more of these. Let me do 36, maybe just 1 more. Maybe it'll be at 25 minutes, and that's a good length for a video. So for 36, I think it's going to fit just like the problem 33 that I just did, in that I could 1 parentheses factor, but I won't be able to 2 parentheses factor. In problem 36, there's a common factor of y that I need to factor out. And when I factor out a y, I'll be left with 8y squared minus 5y and plus 1. Just taking a y away from each term. The last term, if you take the entire term and factor it out, you leave a 1 behind. And then off to the side, I need to factor my 8y squared minus 5y plus 1. I believe this is going to be prime and that this is going to be my answer, but let me just confirm that. I start off multiplying the a and the c. The a is the 8, the c is the 1. Those multiply to 8. This is the second row of my template, so I need double negative numbers. Those double negative numbers need to multiply to 8. And they need to add to negative 5. So my choices, double negative to multiply to 8 would be negative 1 and negative 8. Those multiply, and you'd get 8 if you multiply those. And negative 2 and negative 4 are also double negative, and they multiply to 8. That's good, but what's bad is that when I go to add those, I can't get the negative 5 that I need to get. Easy enough to get the 8 that I need to get, not so easy to get the negative 5. So I found double negative numbers that multiply to 8, but I can't find a pair that add to negative 5. That means this polynomial right here is a prime polynomial, which means I can't do the extra step and to change the factoring that I created on my first step into a factoring that has a common factor times a binomial, but the original problem factored, so my answer isn't prime even though I couldn't go an extra step. This would be the best answer for problem 36. And each of your problems on this page, 35 and 37, are going to do exactly that. They're going to 1 parentheses factor, but they're not going to 2 parentheses factor. That's not a common skill. That's why I buried it at the end of the section, but it's something that you might see, so I thought I'd throw it in. So next few sections are fun. Sections 5.5 and 5.6 are like comic relief. They're way easier than this section. So let's just jump into those in a minute.